Okay, students, so we're here today with a triangle inequality theorem. That's going to be a punchline. We're going to be talking about other things about triangles, how they're constructed, how they're labeled, just really cool properties about triangles themselves. So a lot of this is through the gizmo. If you'd like to do the gizmo by yourself, that's fine. You don't have to listen to my videos, but if you want to listen to my cool, fun videos, just stay here and listen. So let's get warmed up. All right, we will explore how the measures of sides and angles of a triangle are related. You will use this gizmo to discover important inequalities. Oops, meant to highlight inequalities that apply to triangles. An inequality is a relationship in which one quality is greater than or less than another quantity. All right, so we got show side lengths, we got show labels turned on. So how triangles are labeled, this is actually really important. We're right here right now. How triangles are, so notice how on the picture side BC is also called side A. So really we got the triangle over here on the right side of the screen we can look at, we can manipulate. All right, cannot draw on it though, so I'm gonna use this right here to draw on it. Notice how, like BC, let me do it like this. We have side BC. We can call this side lowercase a, and notice how that's opposite of uppercase A. Similarly, BC, or excuse me, AC, we can call that lowercase b, and that's opposite side angle B. So notice how like lowercase and uppercase relate, those mean different things. Side AB, we can call lowercase c, and it's opposite of angle C. So we're just going to fill in this table. Now this is, again, important. This is how triangles are created. All right, so BC was A, CA was lowercase b, and it's opposite of angle B. All right, this is how triangles are labeled. It helps us visualize things. It helps us know what information we have, what information we need, so on and so forth. All right, now we're going to vary the triangle, like just make random triangles. Like, look, I can manipulate this however I want. How do you think AB plus, or A plus B compares to C? So let me just redraw a random triangle really fast. So what this is saying is, like, we got this random triangle. If I add up side A and side B, how do we think it compares to C? So it's basically saying like this blue length compared to this red length, huh? Well, I'm always gonna guess, I'm just gonna assume A plus B is bigger than C. I'm gonna guess the length of the two sides. Now, is this true for all of them? Like, what happens if I make A and B as small as possible? Will that still, looking at this triangle on the right, I think A plus B will still be bigger than C. I think it'll be close. I think the smaller they get, the closer it will be. We can expand it a little bit, kind of like a zoom in. All right, and then pure mathematically, I can write A plus B is greater than C. All right, so activity A, we're gonna get the gizmos ready. Show side length is turned on, show labels is selected. So we're gonna make it all in the gizmos. We're gonna drag the vertices to make the triangle with sides that are all about equal lengths. All right. So that's kind of good, all right? So imagine that the triangle's mapped. Do you think C or A plus B is the shortest route from A to B? So let's zoom in right here. Let's look at this. So basically it's saying, do we think that from A to B, so from A to B, what's shorter, route 1 in green? Or what about this gray route? Go from here to here. Well, I think it's just going to be that green route. That seems way shorter. The shortest distance between 2 points is a straight line. All right. I think C. I'm just going to circle C right here. And we can compare side lengths. So boop, click it. C. Oh my gosh, look, that's pretty cool. C is shorter than AB. As you see in this table on my gizmo, C is 33.29, A plus B is 74.99. So C is clearly shorter. All right, it says select to check. We'll write confirmed. Cool beans. So which is the following true? Case 1, where C is greater than A plus B, or case 2, C is greater than A plus B? It's actually going to be this, all right? And to put it in terms of this gizmo, so this is really important. Case 2, where C is less than A plus B, 33.29. Your numbers might be a little bit different if you have this gizmos up as well as you're listening. That is less than 39.23 plus 35.76. All right, and in simpler terms, 33.29 is less than 74.99. All right. So we're gonna keep this table open and we're gonna create a variety of triangles. Is the inequality above true for all triangles created? So again, like what happens, the smaller, let me make these smaller. Is it possible to get A plus B less than C? It appears no. It appears that this is always true. It doesn't matter what I do. If I do it like this, this, I can't change that value. So is it true for all of them? Yes, sir. Yes. We'll put $sign yes. In Gizmo, we're going to create a situation in which C is equal to A plus B. Well, C is equal to A plus B. I think I can do it like this. Boom. Oh, did it. Nailed it. If you look at my table, they're both 32.75. All right, so I did this. C is equal to A plus B. But what did you notice? If you look on this gizmos, it says it's not a triangle. What do I notice? It's not a triangle. It's another word. It became a line segment. It is a line segment. So is the figure you created still a triangle? Nah, bro. Nope, straight line. All right. So this is for C comparing A and B. All right, notice how we're comparing C to A plus B. Well, I'll just make a random triangle. This seems random enough. All right. Now I'm going to switch it around. A is smaller than B plus C. So in this case right here, we have, well, A is less than B plus C. And that's going to be true for any triangle I make. Just as long as it's a triangle, it's always going to be true. What about B and A plus C? Well, that's still true. All right, B is going to be less than A plus C. All right, how does the sum of two sides of a triangle compare to the third side length? The sum of any two sides is always greater than the third. The sum of any two side lengths is always greater than the third. It doesn't matter which two sides you pick, it has to be bigger than the third side. All right, we're going to talk about this formally and do some problems in the next